All right, this problem says to find the nth degree polynomial function with real coefficients that satisfy the following conditions. And then if you're going to use a graphing calculator, you can graph the function and verify that the real zeros are what they state they are, and make sure that you have the function. So for this particular problem, n is the degree of the function. So in this case, n equals 3. So it's a third degree function. So when I'm done, my function will be x cubed plus something. And it could possibly have a leading coefficient other than a 1. So my zeros are given to be 4 and 2i are my zeros. So this particular problem has one real zero and one imaginary zeros. But remember, imaginary zeros run in conjugate pairs. So if 2i is a 0, then negative 2i is also a 0. So my three zeros, and we know this has to have three zeros because it is a third degree function, are 4, 2i, and negative 2i. So these are my zeros. From my zeros, the next thing I'm going to do is my factors. To get my factors, I need to do my parentheses will be like this, x minus the 0. So x minus 4 is a factor. And then x minus the other 0, so x minus 2i is a factor. And then my third factor is x minus negative 2i. So these are my factors. Now, this factor, I'm going to rewrite it to be x plus 2i. But when you write your factors, it's always x minus whatever the 0 is to come up with your factors. So the next thing that I'm going to do is I'm going to multiply this out. So I'm going to start off by multiplying my two imaginary factors. So I'm going to multiply these two right here. So I'm going to FOIL this out. So x times x is x squared. X times 2i is 2ix. X times negative 2i is negative 2ix. And negative 2i times positive 2i is negative 4i squared. Now, combining like terms here, the positive 2ix and the negative 2ix will cancel each other out, and I will have x squared minus 4i squared. But remember, with imaginary numbers, that I squared is equal to negative 1. So this problem only becomes x squared minus 4 times negative 1. So it becomes x squared plus 4. Then I'm going to bring down this factor, x minus 4, and I'm going to multiply this up. So now my problem becomes x times x squared is x cubed. X times 4x is 4x. Negative 4 times x squared is negative 4x squared. And negative 4 times positive 4 is negative 16. So rewriting this in descending order, I would have x cubed plus negative 4x squared. You could do minus 4x squared here. Plus 4x minus 16. That is my polynomial function. However, the beginning of this problem said that the other stipulation here was, if you can read this right here, is that f of 1 equals 30. So what that means is like if you're going to graph this, that this would be an ordered pair, x comma f of x. And so there's some point on this graph that is 1 comma 30 that needs to be accounted for. So what I want to do is I want to go up here and I want to take that point 130 and I'm going to sub it in for this function here. So there is some leading coefficient here, a sub n, which we'll call our leading coefficient, that if we take 30 and put it in for f of x, and then we sub 1 in for each one of these x's, so 1 cubed plus negative 4 times 1 squared plus 4 times 1 minus 16, that we will find the correct function. So I'm looking for my leading coefficient here. So 1 cubed is 1. 1 squared times negative 4. 1 squared is 1 times negative 4 is negative 4. 4 times 1 is 4 minus 16. And I'm going to solve this equation for a sub n. So the 4's here cancel. 1 minus 16 is negative 15. And I'm going to divide by negative 15 here. So negative 2 is my leading coefficient. So I'm going to go back up here, and I'm going to multiply. I'm going back up to this line right here, and I'm going to multiply everything here by 2. So f of x is going to be equal to negative 2 times x cubed plus negative 4x squared plus 4x minus 16. Distributing my negative 2 through becomes negative 2x cubed plus 8x squared minus 8x plus 32. That is what I'm going to graph, and I'm going to put that into Desmos. So in just a second here, let me write this down so I remember it here. Negative 2x cubed plus 8x squared minus 8x plus 32. And I'm going to go ahead and open up Desmos. So Desmos, if you're not familiar with it, is an online graphing calculator. You can type this into your own graphing calculator. So www.desmos.com. And I'm just going to punch in that function, negative 2x to the third plus 8x to the second minus 8x plus 32. And I'm just going to zoom out here so I can see the graph. So this is what my graph looks like. Now, I can tell by clicking right here, the real zero was 4, and that's where it crosses the x-axis, so I can see that that part of my graph is right. Now, the other stipulation was that at positive 1, it was at 30. So what I'm going to do is I'm going to trace here till I get to 1. So following this graph up until I get to 1 here, and I might need to just kind of adjust my window. The other way I could do this is I could like type in here x equals 1, and I could draw a vertical line right here. And do you see here, let me zoom in at this point here. Do you see how this vertical line, x equals 1, and my original graph, my red function, my cubic function here, crosses at the point 130, so that way I know that that point is right, 130. If I don't have that vertical line in there, so I'll just delete this, if I trace my graph until I get to the x-coordinate of 1, so I'm just following this until I get to 1, and by tracing it, you may not be able to get to exactly 1. It depends on how good you can trace here. But you can see that right there, it's 1.02, 30.041. So if I want to get to exactly 1, the best way to do it is just to type in a vertical line, which tells me that's what x equals 1 is. And then I can look at where my vertical line and my cubic function intersect, and they intersect at the point 130. So I know that I have my right function. So my correct function here is negative 2x cubed plus 8x squared minus 8x plus 32.